Hi, today I'm going to be doing my final presentation here on the Sonoran Desert. I originally wanted to do the Mojave Desert, but kind of as my research came along, I kind of found more interest in the Sonoran Desert. So I figured I would take a little bit more of a look here, which I think is pretty interesting. Uh, so first, the biome and like specific location. This desert is found in southwestern United States and northwestern Mexico. More specifically, it's about 100,000 total square miles consisting of southern Arizona and California, most of the Baja California Peninsula, and most of the state of Sonora, Mexico, which is where it gets its name. It consists of 7 unique subdivisions, which are the lower Colorado Valley, Colorado River Valley. Then there's the Arizona Upland, which there's a little bit of dispute now whether or not that it should actually be considered part of the desert, as it kind of has the more of a uh, more of the traits of a thorn scrub instead. But as of right now, it's still defined as part of the Sonoran Desert. Then there's the plains of Sonora, the Central Gulf Coast, the Vizcaino, Magdalena, and the foothills of Sonora, which you can see in this map right here. The lower Colorado Valley and the Arizona Upland are the only sections that are in the United States, and the rest is like the plains of Sonora is down here in the state of Sonora. The Central Gulf Coast is on this Gulf Coast. The other part of this kind of region is on the Pacific coast side, and the Magdalena region is also here on the Pacific side, a little further south. The main biome is desert, which I guess is in its name, so a little obvious, but I found that the region that they consider kind of around has many other biomes, and they call it the Sonora Desert region, which includes the Sonora Desert itself, but it also includes tundras, coniferous forests, chaparrals, thorn scrubs, tropical forests, and many others, which is pretty interesting to me that they kind of count that in with something that's called an actual desert, which is kind of interesting. First, let's get into some of the more abiotic factors. Uh, they have a biseasonal rainfall pattern, which means that there's approximately equal rainfall in winter and summer. And of the 4 North American deserts, the Sonoran is the wettest and hottest, which is a result of El Nino, which basically is when the trade winds weaken, and that allows the trade winds that leave the Pacific coast weaken, and that allows the hot water to return back, and with that it brings pretty much a ton of different weather patterns. In this case, it makes that region, that along the Sonoran Desert, a lot wetter. Um, and then the lower Colorado River Valley rivals Death Valley in temperature, which I thought was really interesting. We always talk about Death Valley being the hottest place on Earth, but uh, they've recorded that the surface temperatures of the lower Colorado River Valley can reach up to 82 degrees Celsius or 180 degrees Fahrenheit, which is pretty dang hot. That's like, I imagine I'm smoking like a brisket, and that's what temperature I'd be using, which is kind of crazy to me. That's definitely not like the ambient temperature, but that's what like the rocks in the region can get. And then most soils in the region are alluvial with clay and calcium carbonate deposits. And the sandy areas of the soil have much less ability to hold water than the finer soil textures. And then I'll get into a little bit more specific with the uh, with these abiotic factors when we get into the environmental stressors. So some of these stressors include low precipitation, which makes sense in the desert, even though we call it the wettest in the North Americas. Uh, it gets about 50 millimeters to 250 millimeters annual average. And then there's a massive fluctuation in maximum temperatures to minimum temperatures, with maximum temperatures consistently reaching over 40 degrees Celsius, or 104 degrees Fahrenheit. And then across, and so that is definitely causes some big stress in the life that lives here. We can see in this bottom graph here where when temperature increases, both the foothill Palo Verde and Ocotillo both have a decrease in cover as temperature increases. And then as well as when precipitation decreases, we also have a similar change in cover with the creosote bush and the triangle leaf bursage or bursage. So that's kind of an indicator of how stressful these can be for what lives there. And then I found a report on the climate change in the US Southwest, which includes 3 of the 4 North American deserts, which are the Mojave, the Sonoran, and the Great Basin. And that's actually where this graph comes from, but you can see along this southern part of California and Arizona, which is where the Sonoran is the darkest red, indicating the highest temperature increases. But this area as a whole has increased an average of 0.9 degrees Celsius or 1.6 degrees Fahrenheit between 1901 and 2016, which is pretty significant on that scale for that amount of time. And we talked about how the increased temperature and decreased precipitation reduces the cover of Sonoran plants. And we can really kind of only expect that to continue as the region gets hotter. And then another interesting fact I found about the change that we're expecting to see with the Sonoran Desert is that the southeast border of the Sonoran Desert is expected to shrink while the northern border grows, which is just a result of the precipitation in the region, which I thought was very interesting. Finally, let's talk about some of these animal adaptations here. First, I wanted to talk about Gambel's quail, which are these guys up here in the top. And they have a pretty interesting adaptation where it's a behavioral adaptation where they have the ability to select the green food that has enough moisture content to help them ensure that their bodies will get enough moisture even when there's not enough moisture for them to drink, which is kind of a trend along Sonoran animals where they get a lot of their water from their food. This is also the case with the kangaroo rats, who metabolize most of their water they need from their food, and they can produce a very concentrated urine. So while the quail are looking for moisture-rich foods, kangaroo rats mostly eat grain, and their kidneys are developed in a way, so it's more of both of a physiological and a morphological adaptation where they can get all of the water that they need out of the food that they eat. And in this process, they end up producing a very concentrated urine, which means that there's less uh, less water lost as waste. And then finally, I looked into Gila monsters, which are these little lizards down here on the bottom, which they're kind of interesting. They the only native venomous reptile in North America, and their adaptation is that they can store fat in their tails. As you can see here, they've got a fat tail, um, which stores a lot of fat, and this allows them to go months without eating. So whenever food is scarce during dry seasons or times when they're struggling to find food, they can still survive until the next time that food becomes available. And they also eat a lot of eggs. So if there aren't eggs around, then they have time to survive off of that. Anyways, thanks for watching, and thanks for a great semester. Bye.